Myself Pushkal Shukla, Assistant Professor in Computer Science Department at Akgec Engineering College, Ghaziabad. Today I will discuss a theory of inference which is applicable to the BTech third semester students of UP2, and it is the target students is CSC and CSC related branch. The topic which I am going to cover, that is a theory of inference. The prerequisite, that is basic understanding of class 12 mathematics NCERT, basic knowledge of set and algebra rules, understanding of set theory, relations and functions, and algebraic structures, and basic understanding of lattices and Boolean algebra. Now, students are able to develop their logical thinking by using sets, relation functions, mathematical inductions, algebraic structure, lattices and Boolean algebra concepts, and used in upcoming topics like propositions. So, rule of inference. What is the rule of inference? So, rule of inference, in AI we need intelligent computers which can create a new logic from the old logic or by the evidence. So, generating the conclusion. So, generating the conclusion from the evidence and facts is termed as the inference. Inference rules. Inference rules are the templates for generating valid arguments. Inference rules are applied to derive proofs in artificial intelligence, and the proof is a sequence of conclusion that leads to the desired goal. In inference rules, the implication among all the connective play an important role. Following are the some terminology related to the inference rules. So, first, implication. It is one of the logical connective which can be represented as P imply Q. It is a Boolean expression. So, implication means P, let P is a proposition and Q is another proposition, and it is related with P imply Q. So, it is a Boolean expression. So, this is a implication. If P then Q, P implication Q means if P then Q. So, converse of this P imply Q is Q imply P. So, converse, suppose P imply Q is the implication. So, Q imply P is the converse of this implication P imply Q. So, this is the inference rules. Contrapositive. Suppose P imply Q is the implication, then negation of Q imply negation P. Negation of Q imply negation of P is the contrapositive of Boolean expression P imply Q. Then inverse. The negation of implication is called the inverse. Suppose P imply Q is the expression, Boolean expression. So, negation of this, negation of P imply negation of Q is the inverse of this implication. From the above term, some of the compound statements are equivalent to each other, which can prove using truth table. So, for this, here P and Q are the two propositions. So, there are 2 k power 2 propositions are there. So, total possible ways are 2 k power 2, that is 4. Suppose 3 propositions are there. So, 2 k power 3, total 8 possible ways are there to represent this through the truth table. So, here 2 variables are, the 2 propositions are there. So, 2 k power 2 yani ki 4 possible combination are there: true true, true false, false true, and false false. So, P imply Q is, if both statements are true, then it will be true. This condition is true and the conclusion is false, then it will be false. Then this is the condition and this is the conclusion part. So, condition is true and the conclusion is true, condition is false and conclusion is true, then it will be true. And if condition and conclusion both are false, then it will be true. For example, we see by example. Suppose P is a proposition. If proposition P is, my father will give me a new bicycle, and Q is a proposition, I will go to school. So, P imply Q is, if my father will give me a bicycle, then I will go to school. This is true. The purpose is to go to school. So, if my father will give me a bicycle, then I will go to school. This is a true, this is a valid sentence. Second, if my father will give me a bicycle, I will not go to school. This conclusion is false. So, this is false. Yani condition is true and the conclusion is false, then the statement is false. For example, if my father will give me a bicycle, I will not go to school. So, this is a invalid. This is invalid. Purpose is to go to school. Anyhow, my father will not give me a bicycle. False. This is my father will not give me a bicycle. Then I will go to school. This is good. If my father will not give me a bicycle, then I will not go to school. This is also a valid sentence. So, this is the truth table of P imply Q. So, Q imply P is, this is condition and this is conclusion. So, this will be T, T, F, T, this way, P imply Q and Q imply P we can calculate from here. Then negation of Q and negation of P we can calculate by negating this and apply implication, then we will get the result this. And again negation of P imply negation Q, again we calculate negation of P, negation of Q and then implication we apply, we will get the truth table like this. So, hence from the above truth table we can prove that P imply Q is equivalent to negation of Q imply negation P. P imply Q, this is the P imply Q, T F T T and T F T T. So, we say these two expressions are logically equivalent because the truth table is coming same. So, this is coming T F T T, again this coming T F T T. So, logically equivalent sentence. So, we can say okay, P imply Q is equivalent to negation of Q imply negation P and Q imply P is equivalent to this one, Q imply P is equivalent to this. Types of inference rules. So, if you discuss the types, then first one is a modus ponens rules, The modus ponens rules is one of the most important rule of the inference and it states that P and P implies Q is true. What it states? If expression if proposition P is true and P imply Q is true, so this will infer Q will also be true. So, what it infer? P is true and P imply Q is true. Yeah, this is true and this is true. So, therefore, it infer Q is also true. So, based on these two propositions P and P imply Q, we infer a new proposition, that is Q is also true. For example, if I am sleepy then I go to bed, this is P imply Q. I am sleepy is proposition P and I go to bed is proposition Q. So, P imply Q is if I am sleepy then I go to bed, and statement 2, that is P I am sleepy, this is proposition P. So, both are true, P imply Q is true and P is true. So, what we will infer from these two propositions, I go to bed, yani Q is also true. This is part Q, this is Q proposition. So, I infer I go to bed. Hence, we can say that P imply Q is true and P is true, then Q is also true. This is the modus ponens rules. We can see also this by the proof by truth table. Suppose this is proposition P, this is proposition Q, 0 0 0 1 1 0 and 1 1. Here 0 represents false and 1 represents true. So, P imply Q is, that is 0 0 1 0 1. If P imply Q, sorry, this is also 1. So, 0, both statements are this. So, P imply Q, this is also 1, sorry. So, we infer P imply Q is true, and this is P is true. So, here we see P imply Q is true and P is true. So, this will infer Q is also true. Modus tollens. So, modus tollens rules states that if P imply Q is true and negation of Q is true, then negation of P is also true. So, what it states? P imply Q is true and negation of Q is true. So, this will states negation of P is true. We can see by this example, this is the modus tollens rules, P imply Q is true and negation of Q is true, then it will infer negation of P is also true. For example, I am sleepy, then I go to bed. This is P imply Q. This is P and this is Q. So, if I am sleepy, then I go to bed, P imply Q, and I do not go to the bed, this is negation Q. Negation Q, I do not go to bed. So, what I will infer from these two expressions, two propositions, this will infer negation P, and negation P is I am not sleepy. So, I am not sleepy, I am not sleepy. So, we will infer from these two propositions I am not sleepy. So, this is modus tollens rules. Next, hypothetical syllogism. So, the hypothetical syllogism rules states that if P imply Q is true and Q imply R is true, this will infer P imply R is true. This is true, P imply Q and Q imply R. So, P imply R is also true. So, the hypothetical syllogism rules states that if P imply R is true, whenever P imply Q is true and Q imply R is true. So, this will infer P imply R is true. For example, if you have my home key, this is you have my home key, this is a P, then you can unlock my home. So, this is proposition Q. So, for P proposition, if you have my home key and Q proposition, you can unlock my home. So, P imply Q means if you have my home key, then you can unlock my home. If you can unlock my home, this is Q, and you can take my money, this is R. So, if Q imply PR, Q imply R means if you can unlock my home, then you can take my money. So, what we will infer from these two propositions, that is P imply R, if you have my home key, then you can take money from my home, you can take money, you can take my money. So, this is P imply R. So, if you have my home key, this is P, then you can take my money, that is R. So, we will infer from P imply Q and Q imply R, P imply R. So, this is known as the hypothetical syllogism. Next is disjunctive syllogism. Disjunctive syllogism rule states that if P or Q is true and negation of P is true, then Q will also be true. For example, today is Sunday or Monday. So, this is today is Sunday, this is P, and this is a Q, today is Monday. So, P or Q, that is today is Sunday or Monday. Then, and negation P is today is not Sunday, today is not Sunday, this is negation P. So, what we will infer? Today is Monday. So, today is Monday, this is we will infer Q, yani today is Monday. So, this is known as the disjunctive syllogism. Next, addition. The addition rule is one that the common inference rules, and it states that if P is true, then P or Q will also be true. P is true, then P or Q is also true. For example, I have a vanilla ice cream, that is P, and statement 2 is I have a chocolate ice cream. So, I have vanilla or chocolate ice cream. Next, simplification. The simplification rule states that if P and Q, P logical and Q is true, then Q or P will also be true. Next, resolution, that is very important rule, inference rules, that is used in artificial intelligence to prove that any sentence is valid or not. To check the validity of the sentences, we use a resolution and very important techniques in artificial intelligence. So, the resolution rules states that P or Q and negation P or R is true, then Q or R will also be true. So, P or Q is true and negation of P or R is true. So this will infer Q or R will be true. So this negation, this is cancel out and Q or R will be true. So here we see by the two table, here we see this is P or Q is true, this P or Q is true, and negation of P or R is true, then Q or R is true. Again this is also applicable, this is also true. Here we will see this is also. So we will do this. Then predicate logic, that first order predicates. In the topic of propositional logic, we have seen that how to represent statements using the propositional logic, but unfortunately in propositional logic we can only represent the facts which are either true or false. PL, propositional logic, is not sufficient to represent the complex sentences or natural like sentences. The propositional logic has very limiting power, very limited expressive power. Consider the following sentence which cannot be represented using the propositional logic. Just say, for example, some humans are intelligent. Very simple sentences we can represent which is either true or false through the propositional logic, but some sentences which are complex and that is to be used in a natural language, that is a natural language, complex sentences which cannot represent through the propositional logic. So we need a predicate logic, that is the first order logic. For example, some humans are intelligent. So some humans are intelligent, there are some humans are intelligent, like Sachin likes cricket, everyone like a tea. So this type of some, everyone, is this type of sentences, natural sentences cannot be represented through the propositional logic. So we need a first order predicate logic, first order logic to represent this type of sentences. To represent the above sentences, PL logic is not sufficient. We require some more powerful logic, that is known as the first order logic, to represent this. So first order logic, a predicate is an expression of one or more variables defined on some specific domains. A predicate with variable can be made a proposition by either assigning value to the variables or by quantifying the variables. The following are the some examples of predicates. Let EXY denotes x equal to y. Let XABC denotes a plus b plus c equal to 0. So this type of, let MXY denotes x is married with y. So first order logic, also known as the predicate logic, first order predicate logic. First order logic is the powerful language that develops information about the objects in a more easy way and can also express the relationship between those objects. Objects basically A, B, people, numbers, colors, wars, theories, squares, etc. are the objects, and relation, it can be unary relation, it can be such as red, round, adjacent, n-ray relation, such as sister, brother, has color, are the relations actually. And basically in natural language we need a syntax and semantics. There are the two main parts of the natural language, that is syntax and semantics. So how to represent this? We see by examples. These are the constants which are used, like 1, 2, A, John, Mumbai, cats. These are the variables are x, y, z, a, b. Predicates are brothers, fathers, etc. Functions are square root, left leg of, and all. Connectives are, this is and, or, logical and, logical are, negation, implication and by implication. Equalities are, this is the equality symbols. Quantifiers are, for everyone there exists some value, like existential quantifiers and the universal quantifiers. So these are the parts of the predicate logic. So how to write this? For example, we have to represent Ravi and Ajay are brothers. How we can represent this type of sentences through the predicate logic? So we hear that a predicate is a brother. So brother, we write first brother, and then Ravi and Ajay. So Ravi and Ajay. So how we pronunciate, that is Ravi is a brother of Ajay. Ravi is a brother of Ajay. Again we can see like Sita is a wife of Ram. So how we can represent through the predicate logic? So this is wife Sita and Ram. Wife Sita Ram. We cannot change the sequence actually. Wife Ram Sita means Ram is a Sita or wife, that is wrong. So how we can write? We can maintain the sequence. So wife Sita Ram. Sita is a wife of Ram. For example, Ram is a son of Dashrath. So how we can write? That is son, that is Ram and Dashrath. So we can pronunciate, we can say Ram is a son of Dashrath. We cannot change the sequence, Dashrath Ram. So by this way we can represent the sentences, complex sentences, natural like sentences to the predicate logic. Thank you.